Section 2, Video 4. Here we have some figures, and they're asking how many ways can each quadrilateral be classified. So if we look back at our quadrilateral hierarchy, that'll be a great tool to figure out how specific can we be in naming each of these quadrilaterals. So if I'm looking at A, the first quadrilateral, since it's drawn on graph paper, I can see that there are two parallel sides. So I instantly think, well, it's at least a trapezoid. And I also instantly know it's a quadrilateral because there are four sides, and it told me each quadrilateral is classified. So I'm going to go ahead and name it. I know it's a quad, so I know it's a quadrilateral. I know it's a trapezoid because all you need for a trapezoid is the one pair of parallel sides. So I know it's a trapezoid. Now, can I be any more specific? Well, let's see, there's a right trapezoid, which says it has to have a right angle, but I don't see a right angle. And there's an isosceles trapezoid, which means that they're equal length legs. So if I look at these legs, I see that it looks like those are equal length because they both go, they kind of have like a rise of 2 and a run of 4. So that must mean that they are equal. So I know it's also an isosceles trapezoid. So that's the most specific name I could give to it, but it is actually any three of these things. If I look at figure B, I see that it is also a quadrilateral because it has four sides. It looks like it has two pairs of parallel sides. I could go ahead and calculate the slope for the opposite sides, but just looking at it and kind of figuring it out in my head, I know that they are parallel indeed, so I know it's a parallelogram. Because I know it has two pairs, not just one pair like a trapezoid, so that's why I did not call it a trapezoid. And I wonder if I can be any more specific. Does it have, four equal sides? Does it have four right angles? And it definitely doesn't have four right angles, but it does look like it has four equal sides. And if I kind of count, it looks like it's in the middle of those squares, and I go over 1, 2, 3, and then up 1, 2, 3, 4. And I can do the same for both sides. So I think it is indeed a rhombus because it has four equal sides. So that's the most specific name I could give to it, but I can give it all three names. C, it's a quadrilateral again. I see two pairs of parallel sides, so I know it's a parallelogram. Now, that doesn't look like it has four equal sides, but it does look like it has four right angles if I look at these corners here. So I know that it is a rectangle. And does it have, since it doesn't have four equal sides, I know it's not a square. So that's as specific as I can get. But it's a quadrilateral, a parallelogram, and a rectangle. And our last figure, once again, we know it's a quadrilateral. It has just one pair of parallel sides, not two, so it has to be a trapezoid. And is it a special kind of trapezoid? Well, I see this right angle right in here, and I actually see another one over here. So I know it has at least one right angle, so it has to be a right trapezoid. And I can't get any more specific than that. So those are all the names I can give just to those figures. Now we're going to have some questions where you need to answer always, sometimes, or never. And so I'm going to give you some tips for how to answer those questions. So this is when we're referring back to the quadrilateral hierarchy. For when you move down the chart, then it must be sometimes. And this will make a little more sense once we do some examples. If I move up the chart, it's always. And if you move across, is never. Okay, so if you pull out your quadrilateral hierarchy, let's do a couple examples and I'll show you what I mean. So a square is a rectangle. So if I'm starting kind of at the bottom of the hierarchy and I move up a square to a rectangle, I'm moving up. So that means it is always true. And if you think about it logically, a square always has 4 right angles, and that's what a rectangle is. So a square is always a rectangle. A rectangle is a trapezoid. So we started a rectangle, and to get to trapezoid, I have to slide across the chart. So I know it is never true. So I have to slide, I'm sliding that way across the hierarchy, and I know that's not true. And so for the first one, I had to go straight up, and so that's why it's always true. And a quadrilateral is a kite. So I start at the very top of the hierarchy and slide my finger down to kite. And when I'm moving down, I know it's sometimes. So that's saying that a quadrilateral can be a kite, but it isn't always a kite. So that's why it's sometimes a kite.